Hi everyone, I'm Matteo Collina, Platformatic co-founder and CTO. Today we are going to do a deep dive on Platformatic caching. Let's get into it. So Platformatic caching is born out of HTTP, in particular RFC 9111, which depicts the inner working of HTTP caching and defines all the behavior that a cache should do and what it should not do when dealing with HTTP, whatever version of it, HTTP 1, HTTP 2, and so on and so forth. Okay? Based on this standard, okay, what it means is that there is a client and a server, and the server can have a local cache that it can use to store its data. Okay, pretty good, isn't it? How does it work? Well, the user do a get of some product listing, and then this can be a proxy or CDN that do forward that request to your application. That application returns some instruction for the cache to keep that data alive for long. For example, can say as max age, which means share max age 60, which means 60 seconds. So the cache can keep that alive for 60 seconds. So if another request comes in on the same server for that amount of time, the server can serve that request directly without calling it again. Pretty good. After that timeout has passed, the cache is expired, and therefore your application will receive the request again. So how can we do that in Node? Okay, because I'm a Node.js person, JavaScript person. So can we implement all of this in Node.js? Well, you're lucky because because we have just released Undici v7. Undici is part of the Node.js initiative. It's essentially the next version of http.request, if you want to call it that way. And it supports just that. How does it work? Well, first of all, you need to set a new global dispatcher, and you take a new agent and you compose it with an interceptor, which is our cache interceptor, and you add a cache store to it. In this example, we have a SQLite cache store. It's fantastic, okay? And yeah, it just works, okay? You have to do nothing else, and you can just keep caching your request on and on and on and on and on. And it will implement all the things that you need. And now you have HTTP caching built onto your application. And now let's get into it. First thing, we open up and take a look at our Node.js server. This is a create server, which, there is a counter, and we increment the counter every single time we receive a call, and we cache this for 10 seconds. Perfect, okay? So let's run this thing, okay? Cache server node, okay? And now we can curl this, okay? And as you can see, the counter is 0. We set the cache control header. We run it again. The counter is increasing, no problem, okay? Now let's take a look at our cache client. Our cache client is the same one we have seen in the example. We are using the SQLite cache store, but there is also a memory cache store that you can use if you want. Pretty great. That's basically what it is. We are issuing the request 2 times and see what we get. Okay, now we can run this. Oh, it's not working. Why? Well, because the SQLite is behind a flag, so we need to run it. And here we go. Hello world 3. Okay, but we do, and it's still 3. Okay, but now if we wait 10 seconds, it's now 4. Okay, and if you run it again, stays 4 for a bit, and so on and so forth. Okay, multiple run, no in memory, stored on disk is essential. Perfect. Okay, so let's go back to the slides. Okay, so what can we do now with this? Well, we can easily use this to implement caching in a microservice network where each service can have its local cache, so it can speed up things quite a lot. See, it's pretty good, right? Well, there is a catch though. Why? Do you know? Well, how can you invalidate the cache of a client? Okay, you need to invalidate the cache in all those little copies everywhere so that you can get things done. How can we do that? Well, you can't really invalidate the client cache. It's not part of the standard, okay? And because it's not part of the standard, CDN and reverse CDNs and reverse proxies all implement some proprietary APIs to do so. But how can we do it, right? Oh, well, I've been wondering for a while this problem, and and we decided to fix it, or maybe try to fix it. So before we go that though, let's talk a little bit of our VAT application server, because that's what we use for solving the cache problem and the invalidation problem. So we need to look into it. So first of all, VAT is abstracts away all time-consuming tasks like monitoring, logging, tracing, and supports all kind of full-stack applications. Supports all the frameworks like Express, Fastify, Koa, but also the Meta framework for front end like Next, Astro, Remix, or anything using Vite. Works great with all of them. In any of those services are run in separate threads to guarantee a minimum level of isolation. So they can just run as they were designed, and without much problem. They can communicate with each other using either an in-mesh network, in-process mesh network, which works very well, or just old school TCP. And VAT can scale and balance them across multiple threads and so on, requests across multiple threads. Works well. Well, this is an example of a VAT-based architecture. We have a composer, which is essentially very similar in the purpose to an API gateway. Here you can see it. Then we have a Node.js app, and then we have a Fastify app or a Next.js frontend, and they can communicate with each other. In fact, there is this concept of in-process mesh, which essentially allow us to create from one service to another just doing fetch or using unchi.request. Both works very well, and you can get amazing performance out of this setup. You can also instrument any application. In fact, you can add it to Next, for example, super easily. Okay, you just create a new file called vat.json running vat pm import, and that's what it is. Okay, so and there is auto completion in the JSON, so it's, to be honest, it's easy to fill. Anyhow, very easy to set up. You can get started. We have an amazing piece of documentation, so you can check that out. However, how do we have done that with? How do we use? However, okay. How does caching work in VAT? Well, in VAT, we have one local cache for an application, for the whole application server running, and each service can put data inside that shared cache. Works very well because then if two services are calling the same endpoint, they get the data from the exact same cache. I think it's pretty good. Okay. However, that's not finished, because it is a shared cache, we can also implement invalidations. How does it work? Well, if the data is changing, then we can actually invalidate it. Okay, we can invalidate the content of previous responses from the source by just calling an API. How does it work? Well, first of all, we need to enable caching, and we need to basically in the root VAT.json file, we need to specify HTTP cache. Just enable it. Once it's enabled, okay, we can use something called cache tags. Cache tags are unique identifiers for a resource. Essentially, for example, product 42 or product-id, essentially to identifying a product. You can also use UUIDs as long as you can get them from a database or a known piece, and this does not change across the lifetime of that entity. Then you can specify those cache tags as a header in your response. Seems great, right? Well, yes, it is. It is great, because then you can use them to invalidate. Well, you can invalidate by specifying the path and the method and the headers. Done. Okay. Or you can invalidate by using those cache tags. the cache tags. Invalidating by using the cache tags is actually pretty great, because you can use them to invalidate all the requests that have been done across all services. Seems fantastic. Okay. And now let's see if the demo gods are with me again. So it is a cache demo. What have we got? We got a few services. We have a main services, which is essentially our composer. Okay, and we are composing two services, one internal, one the other one. The two services are very easy. They're just essentially expose just a bunch of Fastify routes. Internal expose a cache counter API, which is the same thing we had before, with an Xmax age of 600 seconds, which, 10 minutes. So cache forever, essentially, for us. And we have a request to invalidate that route, okay, and a request to invalidate by cache tags. Okay. We have also another services, and this other service is calling our cache counter route as before, okay, and we are returning the same cache tag of that request, but we also add one more field, okay, which is very common, especially in microservice network. Call another microservice, add some metadata to it. To be honest, it's probably the most common case. Okay, let's run this and see how it goes. Okay, is now running. And now this is our Platformatic composer, and you see this is composing two OpenAPI schema, and we can open our OpenAPI. Great. So we have a bunch of routes. We have internal cache counter, for example. We can try this thing. Okay. And here we run it, and you see this is cache forever, counter 0, counter never incremented. Okay. Now, very interesting. We have never fired the cache counter, the second route, the other cache counter, the other microservice. So, we can try this, and this still returns 0 as the counter, because it's accessing the same cache data that was put in the cache by our composer. Wow. Okay. So, the data is pretty much consistent. Okay. Of course, we can also try to invalidate the cache counter. Okay. So we can invalidate the cache counter. Okay. And now, it's failing. Yes, because I need to put none as the body. We have no body. Okay. So this is done, and the cache has been invalidated. Okay. So if I go back here now, okay, and I can check my headers, I run it again, and now counter is 1. Okay. And you see that we have this cache counter tag, and I'm copying it because I will use it in a second. Okay. At the same time, if I run the other cache counter, okay, and I run it again, this value has been updated too, okay, because the cache now is, was wiped, and it stays the same, okay. Very interesting. I can also go and use the invalidate cache tag API in a very similar fashion. Okay, so I have the tags query parameter. I can pass my cache counter tag here, which is unique tag. I run it again. I got the exact same problem. Run this. It's invalidated. Then I run my cache again, and now again, even this was invalidated, and this was done too. Okay, and this is updated to 2. But frankly, everything was absolutely and fantastically cached. Right, not bad. All of this, it's in process. Okay, what if we need a distributed cache across multiple processes? Like all of these happen inside the same process. So I have multiple services running in the process, and they have their shared cache. What if you need a distributed one? Okay, well, all of these, VATPM is Apache 2, is open source. All of that is open source, and doing all this stuff requires a paid product. So let me introduce you to our Platformatic Intelligent Command Center, which allows you to monitor, manage, and optimize all your node application, providing all the insight you need to run them at their best. You can call us if you need any of these things, but let's talk a little bit about how that helps with invalidation. So if you need 2 applications or multiple copy of the same applications, the concept was exactly the same, we have, you can, every single one has a shared cache, okay? Every single application has its own shared cache local to them. However, these are also multiple copies, and how do you keep them in sync? Well, in fact, we all of these is being kept in sync by the Platformatic Intelligent Command Center that received the cache data and keep it safe, but also allows to distribute make sure that each copy in each application is up to date. Works very well. But how do you do invalidations? Well, because we have the Intelligent Command Center, then we can actually invalidate a cache entry, and then invalidation are distributed everywhere as well. Okay, fixed, done. Did we solve caching? We tried. Okay. Well, we also provide a very interesting UI for investigating and knowing what's being cached, and you can even go down and invalidate every single entry individually. So gone are the days of, oh, there is an error in this page, I need to wipe all the cache. You can just go in and just invalidate that specifically. You don't need to call our the API and build yourself a UI for that. You can just open the command center and have a UI. Here is the final slide on our Platformatic Intelligent Command Center. We provide you the node core metrics that matter. We provide you automated taxonomy and telemetry so that you can understand how your application is behaving and who is your application communicating to. And you can show all the user activities. Of course, we also support all the caching details now. Thank you very much for watching. Follow us at Platformatic and, see you soon. Bye.